So now other stability factors, see from the equation it is very clear that for thermal stability, S value should be as small as possible. It should be very, very small. Okay, the value of S should be very, very small, which will ensure better thermal stability. Okay, the variation should be less. See, logically, the S is going to be DIC by DIC naught, which means that the variation of IC. So if the variation of IC is very, very small, then the stability is very high, right? So that is logically told here. So the value of S should be very, very small for the circuit to have better thermal stability. Okay, so stability factor, the general question you may get, what is the value of stability factor? So it should be very, very small. Ideally, it should be 0, which means the variation should not be there for any effect in temperature. But practically, you cannot say that because temperature effects cannot be ignored. So you can definitely say some variation will be there, but that variation should be as small as possible. Now the other two parameters, S dash and S double dash. So S dash, we give the priority to VBE second. So S dash equal to dou IC by dou VBE, and S double dash equal to dou IC by dou beta. So these are the two expressions for S dash and S double dash. And see, if you have one variable, we use d by dx differentiation. Since we are having three variables here, even though at a time only one variable is considered, it is logical to use dou by dou x, partial derivative. Okay, so that is why several books use d, several books use dou, several books use delta. So all the notations are correct, but logical to use dou. So in the first expression we use delta but d, but after that we didn't use d because it is logical to use dou, because the IC depends on three variables. Even though only one variable is considered, remaining two are going to be constant. Okay, so S dash is variation of IC with respect to VBE, and S double dash is variation of IC with respect to beta. See, all these variations will be 0 if the transistor is an ideal transistor. See, you know IC equal to beta into IB. So far, we have considered beta is constant, correct? Current amplification factor was considered to be constant. But what does the actual scenario says? Beta is not constant. Beta is also varying with respect to temperature. Upper, whatever concept we have studied till now, what is the underlying one line has to be mentioned in whatever concept we studied till now in BJT. Having read about stability factors, can you say that underlying line, or can you say the disclaimer what you have to put in BJT? What is the disclaimer we have to put for all the formulas which we use in BJT? What is disclaimer? Before using any product, they will be putting it in disclaimer, right? So use this product under so and so condition. So adhe mari BJT, what disclaimer we have to put? What disclaimer if we put, everybody will be using it very, very carefully. Yes, I want some answer. All the concepts in BJT, what you have studied is valid for what? Valid for what condition? Valid for constant. I have given 50% of answer. Constant dash operation. Constant dash operation. What is the dash? Constant. Constant. Make a guess. All the parameters of BJT will work under constant temperature. If temperature is going to change, even the constant parameters like VBE, what you consider as 0.7 volt, beta, what you consider as current amplification factor, all these constant parameters will also change with temperature. That is a very, very important thing you have to understand in BJT. Okay.